All right. So you remember the last video when we covered the whole bank pre-compile? I mean, that was all about moving money around, depositing stuff, withdrawing stuff, the usual. But now I guess it's time to talk about what happens when you actually want to do something with that money, right? Like, trade it, swap it, make some big brain moves. So yeah, buckle up because the story of how we got here, like I mean, to this point with all these different exchanges and stuff, it's actually a total roller coaster. And I'm talking about like brilliant ideas, spectacular failures, and billions of dollars just vanishing into the void. So yeah, I mean, it's fun. Let's go. Okay, so let me paint you a picture of the dark ages, right? So it's 2015. Bitcoin's been around for a few years. Ethereum just launched. You're sitting there with some crypto and you want to trade it, right? Maybe you want to buy some Bitcoin with your dollars or sell your Bitcoin for Ethereum, whatever. So your options are basically just one, which is like centralized exchanges. Companies, actual companies with servers and employees and customer support tickets that never gets answered. Places like Binance or Kraken or even Coinbase. And the deal was pretty simple. You send them your precious crypto, they make a pinky promise to keep it safe, and in return, you get to trade on their platform, right? So these crypto exchanges at the time they weren't doing anything revolutionary. I mean, they were literally copying the model that typical stock exchanges had been using since people were trading shares on Wall Street while using or wearing that silly hats, right? So these exchanges they had these things called order books. I mean, the way it works is pretty simple. Like you would log in, you would place an order saying that I'll buy one Bitcoin for like $400, right? And that order would sit there visible to everyone until someone comes along who wants to sell at that price, and then boom, the crypto exchange would just match you guys up and everyone's happy. I mean, that model worked. It worked pretty well. Actually, of course, like the whole order book model, it like Wall Street wouldn't use it if it was silly, right? I mean, it's Wall Street. So, but the thing is with crypto exchanges, there was this one tiny problem. Okay. The thing is, you didn't actually own your coins while they were sitting on the exchanges. Okay, the crypto exchanges held them in their custody, in their wallets, or in their server. You just had this IOU in their database, this little number saying, yeah, I mean, user number 123 owns 1.5 Bitcoin. And you had to trust that they were actually holding that Bitcoin for you and that they weren't going to run away with it and that their security was good enough and that they wouldn't freeze your account because some algorithm decided you looked a bit suspicious, right? So, how did that trust thing actually work out? Well, let me tell you a horror story. Okay, in 2014, Mt. Gox, which was handling like 70 percentage of all Bitcoin trading in the world at that time, making it one of the biggest exchanges out there, right? Got hacked. Okay, I'm putting hacked in quotes because to this day nobody is entirely sure what really happened. But the result was just the same, right? 850,000 Bitcoin vanished. $500 million at the time, gone. I mean, people lost their entire life savings. And Mount Gox just went, oops, guys, we are now bankrupt, so we can't do anything about it. But wait, I mean, it gets better because this wasn't a one time thing. That was actually a start of a trend. Because when you look back in 2018, you had the Coincheck hack, which lost around $500 million. In 2019, you had Cryptopia, which gets hacked and goes bankrupt. In 2016, you had Bitfinex, which lost around 120,000 Bitcoin. So the list basically just goes on and on and on, right? It was like watching a very slow and very expensive game of dominoes where every domino that falls is basically someone's retirement fund. And then just when you thought that we have learned our lesson and we can do better, 2022 rolls around and FTX explodes in the most spectacular fashion possible, right? Turns out Sam Bankman Fried, the guy with the bad haircut who kept appearing on TV talking about effective altruism, was running FTX like his personal piggy bank. He was taking customers' deposit money that people thought was safely sitting in their exchange accounts and gambling with it. I mean, just straight up gambling, using it to make risky bet through his trading firm. right? And when those bets basically went south, 8 billion in customer funds gone. People who had their life savings on FTX woke up one morning to find out that they owned nothing. The exchange filed for bankruptcy. Sam's in prison now, and the whole thing was basically a big disaster. So yeah, the whole note your key, note your crypto mantra that Bitcoin maxis kept shouting from the rooftops. Turns out they weren't just being paranoid; they were actually pattern recognition machines who had seen this movie before, right? So these centralized exchanges actually had amazing trading infrastructure with their order books and their matchmaking engines and their sophisticated features. The actual trading experience was pretty good, but the custody model, the part where you had to hand over your coins and just hope that they didn't steal them or lose them or get hacked, that part was fundamentally and catastrophically broken, right? So around 2017, 2018, right after watching multiple exchanges implode and billions of dollars disappear, some developers had this absolutely brilliant light bulb moment. But I mean, they thought, like, wait a second, we have smart contracts now, right? Ethereum is a big thing. Like, they have smart contracts now. What if we could build exchanges on the blockchain itself, right? Instead of sending your coins to a company, what if the trading happens directly on a chain like Ethereum, where everything's transparent and nobody can run away with the money? I mean, the vision was beautiful. Build decentralized exchanges where you keep custody of your coins the entire time. The exchange is just code running on a blockchain. No company, no CEO who might be secretly insane, no server that can get hacked, just math and cryptography doing their thing. Right? So, this was the birth of what we now call DeFi or decentralized finance, and everyone got super hyped about it. I mean, finally, we could have the cake and eat it too. Professional trading infrastructure without having to trust sketchy companies. Everybody thought that the future was here. I mean, it kind of was, but yeah, let's talk about it more. Okay, now here's where things get interesting. And by interesting, I mean absolutely frustrating in a way that makes you want to throw your computer out a window. You see, these early decentralized exchange builders, they sat down to code their decentralized exchanges and thought, okay, we need order books because that's how real trading works. I mean, it made sense, right? Order books had been the standard for centuries. It had been the trading standard for centuries. So they started building order books on blockchains like Ethereum, and then they hit a wall. And I mean a big insurmountable, oh crap, this is actually impossible wall. Okay, so the problem was something called as front running, and it was so much worse on blockchain than anyone has anticipated. Right? See, in traditional finance, front running is basically illegal and considered super sketchy. Like, if you're a broker, if you're a stockbroker, and you see your client's big order coming in, and you basically rush to trade ahead of them, that's fraud. Okay, you can go to jail. But on a public blockchain where every transaction sits in a mempool waiting to be processed, friend running became trivially easy and completely legal because in blockchain code is low and there is no securities regulator for decentralized exchanges. So here's what would happen. You would place an order on one of these early DEXs or decentralized exchanges. Let's say you want to buy 10 Ethereum at market price, right? So your transaction goes into the mempool, which is basically a waiting room for transactions that haven't been included in the block yet. And here's the thing: the mempool is public, meaning every bot, every miner, every degen with a Raspberry Pi board can see your transaction sitting there and act on it. So some bot sees your order and goes, "Oh, look, this guy wants to buy 10 ETH at at market price. I'll submit my transaction with a higher fee so that it gets processed first. Buy the ETH before the guy, and when the guy's order drives up the price, I'll immediately sell at a profit." That's exactly what happens, right? The boat front runs you, makes money off your trade, and you get terrible execution every single time. Now, this was absolutely devastating for these early blockchain order books. It made them almost unusable for anyone who wasn't running sophisticated, board infrastructure themselves. The order book model that had worked so well on centralized exchanges just didn't work on public blockchains, because the very thing that made blockchains trustworthy, which is their transparent nature, made order books vulnerable. So the DeFi folks stood there looking at this problem, and they had to make a choice. They could either give up on decentralized exchanges entirely and admit defeat, or they could get creative and try something completely different. Something weird, some weird experimental approach that nobody had really tried before. Something that might not suffer from the whole front running problem, even if it meant sacrificing some of the benefits of the order book. So that's where our story really begins. And that's when things started getting really, really weird. Okay, so around 2019, some absolute geniuses figured out that maybe, just maybe, you don't need to use order books and match buyers with sellers like some kind of blockchain dating service, right? What if we just used math instead? And they were not even talking about complicated math. Like, they were talking about simple algebra that you probably learned in high school, right? So that is how the whole automated market makers were created, or AMM if you're cool, right? So here is how it works. Instead of waiting around for Bob to decide if he wants to sell you his ETH, you just dump your USDC into a magical pool, and the pool spits out ETH based on a formula. I mean, the most famous formula is X times Y equals K. I mean, it sounds fancy, but it's basically a way of saying that keep the pools balanced at all times, right? So let's say you have a pool with 100 ETH and 200,000 USDC, right? That means each ETH is worth around 2K, like $2,000. So someone buys one ETH. Now the pool has less ETH, so the price of the ETH automatically goes up to keep that magical constant number happy. It's actually pretty elegant when you think about it. And suddenly everyone was like, holy crap, I can trade anytime. 3 a.m. on a Tuesday, no problem. The math doesn't sleep. The math doesn't take lunch breaks. The math doesn't care if it's Christmas. And the companies who actually use this, like Uniswap and all, they absolutely blew up. Curve finance became a thing. Sushi Swap, which basically forked Uniswap, and somehow that worked out. So your friend Bob started providing liquidity and started acting like he was running the Goldman Sachs from his laptop at Starbucks, right? So people were making passive income just by depositing tokens into the pool. It felt like the future has arrived. I mean, twice. Like we already had it once before, but yeah, I mean, this was something cool. So yeah, but the thing is, what nobody tells beginners about AMMs, especially when they're trying to get you hyped about providing liquidity and earn fees, is that AMMs are kind of expensive if you're not careful. Like really expensive if you're trying to trade serious science. Okay, let's say you want to buy a decent chunk of ETH, like the 10 ETH from the pool that we talked about earlier, like the pool that has 100 ETH, right? So since the pool only has 100 ETH in total, if you're trying to buy 10 ETH from it, you are buying 10 percentage of the entire thing. Now watch what happens. And I mean, this is where it gets painful, because your first ETH costs you $2,000, right? Cool. That, I mean, that can be the market price. But your second ETH, I mean, the pool, when you're buying your second ETH, the pool has already shifted because you took out the first ETH. So now it costs you 2010, right? $2,010. Your third ETH will cost you $2,020, because the total pool keeps shifting against you. So by the time you get to your 10th ETH, you're paying like, 2.1K for something that was worth around 2K when you started, right? So do the math, and you're paid an average of 2050 per ETH instead of 2000. And that extra 500 that you lost, that's what we call slippage. And it's basically the pool going, hey buddy, you're moving the market here, so it's going to cost you, right? And here's the I mean, here's the real problem. Like this happens every single time. I mean, the bigger your trade, the worse it gets. It's not a bug; it's actually a feature. I mean, AMMs literally punish you for trading size. Professional traders absolutely hates this, like viscerally, deeply, profoundly hates this. Because in traditional finance, you can execute a million dollar trade without moving the market much if there's a good liquidity. But on an AMM, you're basically paying a tax for every unit you trade. And remember how I said AMM solved the friend running problem that plagued order books? I mean, if you don't, that's because I probably didn't say it, and it really didn't help with the friend running. I mean, turns out, I mean, still, like even if you're using AMMs, the bots still watch the mempools, right? They can see your big trade coming in. They can jump in front of you with higher gas fee, shift the market against you, and profit off your pain, right? It's like someone cutting in line at a coffee shop, except instead of just annoying you, they make thousands of dollars doing it. So AMM solved some problems but created a whole new set of issues, that they had to solve again. I mean, that's classic crypto move, honestly, but yeah, that happened. But in the real world, like when you look at, like when all this was going on in the crypto side, in the real world, every serious exchange that ever existed, like the New York Stock Exchange or NASDAQ or Binance or Coinbase Pro or your local stock exchange, literally every professional trading venue on planet Earth, they were still using order books. And some of them have been using it for like 400 years because it actually works really well. Now, when you look at it, order book is dead simple. I mean, conceptually, it's just two lists. Okay, like on one side, you got buyers saying that they are willing to pay, and on the other side, you got sellers saying that that they want this, right? So, for example, Alice says, "I'll pay, 41,000 for one Bitcoin." Bob says, "I'll pay 40,500 for one Bitcoin." Or Carol says, "I'll pay 40,000 for one Bitcoin," right? Meanwhile, on the sell side, Dave says, I'll sell one Bitcoin for 42,000. Emma says, "I'll sell one Bitcoin for 42.5 K," right? Frank says, "I'll sell for 43K." Right? So the market price is somewhere in that gap between Alice's highest buy offer at 41K and Dave's lowest sell offer at 42K. So you want to buy right now, you pay Dave 42K. Want to sell right now, you get Alice's 41K. But here's where it gets really cool, and that's why, I mean, professionals love order books. You don't have to trade right now. You can just park your order in the book and walk away. You can say, "Hey, if Bitcoin drops below 40K dollars, buy me one." And your order just sits there patiently waiting. It could be hours, it could be days, weeks. You're not watching the screen, you're not refreshing anything. And when the price eventually hits your target, boom, your order fills automatically. You set it and you forget it. And professional traders absolutely love the system because there is no slippage eating their profits. They can see exactly what everyone is willing to pay at every price level, which means real price discovery is happening. Large trades don't automatically destroy them, and the market actually reflects what human things think things are worth, not just what some mathematical formula spits out. It's legitimately how serious money has been traded for centuries, and there is a good reason for that. It actually works. Okay, so here's the obvious question that probably just popped up in your head. I mean, if order books are so freaking great and everyone in traditional finance uses them and they are clearly superior for actual trading, why didn't DeFi just use order books from the start, right? I mean, why did they even bother with AMMs? I mean, it's basically the same answer as before, front running, and it's absolutely brutal on blockchains, as I've said before. You see, the thing is, like, I mean, front running basically destroys the whole concept of order books, right? Which is why early DEXs, I mean, decentralized exchanges, looked at this problem and mostly gave up. I mean, they went with AMMs instead because at least AMMs offered some protection through their mathematical formulas. Even if they introduced slippage, It was a compromise and honestly not a great one, but it was better than getting front run into oblivion, right? So this is where Injective did something legitimately clever. I genuinely say, I say this with sincerity because they looked at the whole situation, and Injective looked at this whole situation and went, okay, so order books are clearly superior for actual trading, like objectively better in almost every way. And front running is literally the only problem preventing people from using them on blockchains, right? So what if we just eliminate front running? I mean, and then they basically figured out how to do it. It's so simple, but it's so brilliant at the same time. But first, before we talk about all these things, let's just let's just try and understand what they actually build. It's called the Central Limit Order Book, or CLOB, or I'll just call it CLOB. And it's basically the fancy industry term for what we have been calling order books this whole time. It's basically the standard architecture that virtually every major exchange in traditional finance use, like stock exchange, commodity markets, forex platforms, you name it. The central part just means that all the orders are collected in one place instead of being scattered across different venues, right? And the limit order part refers to orders where you specify a price limit, like buy one BTC at 41K or better, right? As opposed to market orders where you just yell, "Give me whatever is available right now." Right. So here's how a traditional club works in real world. Like, it collects all the buy orders, which are basically the bids, and the sell orders, which are basically the offers, and organizes them neatly by different price levels. Right. The biggest bid and the lowest ask create what's called the spread, or the current market price. So orders get matched continuously in real time on a price time priority basis, meaning the best price gets filled first, and if multiple orders are at the same price, whoever submitted their orders first gets the priority. First come, first served, right? So it's like a really fast, really efficient line at the DMV, right? Except the line actually moves and nobody has an existential crisis by doing so. So this whole continuous matching is great for speed and efficiency. Orders are executed in microseconds. High frequency trading firms loves this. Markets feels alive and super responsive. But here's the problem: when you try to port this exact model to blockchain, the whole continuous real time first come first serve thing, that's basically a front runner's paradise. On a blockchain, transactions don't actually execute instantly, which we already talked about. They sit in a mempool and stuff, and bots can see your orders coming and pay higher fees to jump ahead of you and execute their trade before yours goes through. Right? They can literally see what you are about to do and front run before your transaction even make it to on chain. Right? So all this is absolutely brutal. So Injective looked at this and said, what if we keep the order book structure because it's genuinely superior, but completely change how orders gets matched? Instead of continuous matching where orders execute in real time as they arrive, what if we batch everything together and process it all at once? So their solution is called the frequent batch auction model, or the FBA, if you like, snappy short forms. And honestly, once you understand it, it's kind of brilliant in its simplicity. Here's the key thing: like, instead of matching orders continuously like a traditional club, Injective collects all orders that arrive during a discrete time window, typically like one block, and then matches them all simultaneously at one uniform clearing price. Everything happens in batches at the end of each block, hence the name. So on Injective, these batch auctions execute approximately around every 0.65 seconds, right? Which is pretty fast. You're not waiting around for minutes, just blink and your batch processes. So let me break down what makes this fundamentally different, because different from the traditional stuff, because this is an entirely different ball game. right? So in a traditional, central limit order book, which is used on Wall Street or Binance or wherever, orders gets matched continuously as they arrive. First come, first serve, priority rules, everything, right? Each trade can potentially get a different execution price depending on when it hits the order book. It's lightning fast and feels incredibly responsive, but on a blockchain, that speed that speed actually becomes a vulnerability. Orders are visible in real time, sitting there in mempools like sitting ducks, just begging to be front run. But on Injective's CLOB, with the whole batch auction thing, it just changes everything because orders are collected over a time interval which is like one block or like 0.65 seconds. All orders in the batch gets matched simultaneously at the end, and everybody gets their fair clearing price. There is no first in line advantage anymore, which means front running becomes literally impossible. I mean, there is no front running because there is no line to front run, right? Orders remain sealed until the batch processes. They are hidden. Nobody can see what you submitted until it's too late to do anything about it. So the FBA model actually introduces three critical features that makes this whole thing work, and each one is essential to the whole thing functioning. I mean, the first, there are discrete time intervals for accepting orders. Each block is one auction, and at the end of the block, everything processes at the same time. Second, there is a uniform clearing price for all the matched orders in that batch, not different prices for different people. One price, fair and square. And third, and this is the most crucial, there is a sealed bid mechanism where orders remain unpublished until the auction interval ends. Your order is hidden in something sort of like a sealed envelope until the batch processes. That sealed bid thing is what really kills the front running bots or whoever is trying to do the front running, right? In a traditional club, your orders become visible the moment you submit it. Everyone can see it sitting in the order book. On a blockchain, that means bots can come in and do their thing. But with Injective's batch auctions, your order is sealed and hidden until the entire batch processes, right? So by the time anyone sees what you've submitted, it's too late. It's basically too late to front run, right? It's like submitting a sealed envelope to an auction house instead of shouting your bid out loud where everybody can hear, right? So let me give you a bit more mathematical or concrete example, because I think this stuff makes much more sense with actual numbers, right? So picture this batch of orders all arriving during the same time window. Like Alice says, buy one ETH at 2.5k. Bob says, buy one ETH at 2.4k. Charlie says, buy one ETH at 2.6k. And Diana says, sell one ETH for like 2.5k or whatever, right? And somebody else like Mary comes along and says sell one ETH for 2.6k. So on a normal traditional club, which is operating in continuous mode, these would get matched one by one as they arrive in the order book queue, right? Alice and Charlie might match first at one price, then Bob and Diana would match at a different price. But plus, bots could potentially see these orders coming in the mempool, and they will try to squeeze in between with higher fees. It would be a mess, right? So orders, I mean, like orders executing at different prices, bots jumping in, chaos. That's the summary, right? But with Injective's batch option, something completely different happens. The system looks at all of these orders together as a group at the end of the block. It's like and the algorithm basically calculates one single fair clearing price for the entire batch based on where the supply meets the demand. Let's say the clearing price works out to, I don't know, $2525, right? $2,525 based on the full picture of buy and sell pressure. Then everyone who can match at that price trades at that exact same price all at once simultaneously. So in this example, Alice buys orders at 2.5k. Like Alice's buy order at 2.5k doesn't match because she wasn't willing to pay 2,525. Charlie's sell order at 2.6K doesn't match because he wanted more. But if Diana had said sell at 2.5K instead of 2,550, then Alice and Diana would both trade at whatever fair clearing price the batch auction calculated. Maybe 2.5K, maybe 2,510. Depends on all the other orders in the batch. The point is, no queue, no first in line, no I got here before you, so I get priority. Just one fair price for everyone in the batch. So front running boards are sitting there like, but I need to be ahead of someone to make money. Except there is no ahead anymore. It's a batch. Everyone's simultaneous. There is no jumping. There is no jumping in the queue. The whole concept of front running just stops working. It's like trying to cut in a line where there is no line. Just a circle of people being served at the exact same moment. And here's the massive advantage that doesn't get talked enough. Like market makers get ample time to cancel stale orders before high frequency traders can execute against them. In a traditional continuous CLOB or central limit order book, if the market suddenly moves and your limit order is low, your limit order is now mispriced, you have got maybe milliseconds to cancel it before some bots picks you off. Blink and you're done. But with batch auctions happening every 0.65 seconds, you actually have a fighting chance to update or cancel your orders when market conditions shift. The professionals providing liquidity actually gets a fair shake instead of getting destroyed by bots with microsecond advantages. So Injective basically said, let's take the best part of order books that Wall Street's been using for centuries and add some anti-friend running magic sauce with the batch auction. And what we ended up with is honestly kind of remarkable when you think about the engineering that actually went into it. I mean, first of all, there is no slippage. Like there is zero slippage. Your order executes at a fair clearing price that's calculated for the entire batch, not progressively worse price as you eat through the order book. You're not getting punished for trading size. You're getting the same fair treatment whether you're buying 1 ETH or 100 ETH. Professional traders can actually execute large orders without getting destroyed, which is kind of a big deal. I mean, remember how AMMs would punish you more and more with each unit you bought? Yeah, I mean, that part is gone. The clearing price is the clearing price, period. Right? So the second and the most obvious one is there is no front running. Bots literally cannot jump ahead of you because there is no ahead. Everyone in the batch is equal. It doesn't matter if you paid higher gas fee or if your transaction arrived first, everyone gets the same price. The playing field is actually level for once. After years of watching bots extract value from every single transaction, this feels almost too good to be true. But it's real and it works. And the third thing is you get real price discovery, like actual humans setting actual prices on what they think things are worth, not just some mathematical formula spitting it out. Right? Order books show you exactly what buyers are willing to pay and what sellers are asking at every price level. You can see market depth. You can see where support and resistance might be forming. You can gauge sentiment by looking at the order distribution. It's transparent in a way that actually matters for making more informed trading decisions. And fourth, it's still professional grade infrastructure that institutions can actually use. Market makers and serious trading firms can actually participate without getting destroyed by MEV bots. By processing transactions in discrete intervals with sealed bids and uniform clearing prices, the system prevents maximum extractable value strategies that has plagued DeFi since day one. This means actual liquidity providers who wants to make markets, who wants to make, markets can do so profitably, which means better liquidity for everybody. It's a virtuous cycle instead of a death spiral of AMMs where liquidity providers constantly get wrecked. And fifth, which is like the most important, it's still fully decentralized. Everything happens on chain. There is no trusted intermediary, no company holding your fund, no FTX style shenanigans possible. You get all the benefits of DeFi, self custody, transparency, permissionless access, no CEO who might be secretly gambling with your customer deposits, combined with the trading experience of a centralized exchange. It's like the best of both worlds without the compromise that plagued earlier DEX design. Now, in order to drive this point through, here's a stat that really tells you the story, right? Despite, I think, maintaining only about 30 to 70 million in total value locked, which is tiny compared to some big AMMs, Injective has facilitated over 55 billion in trading volume across spot and derivative markets. Most days they are doing over 100 million in trading volumes. That's absolutely insane capital efficiency. I mean, AMMs actually need billions locked up to facilitate that kind of volume. But Injective does it with a fraction of TVL because order books are just fundamentally more capital efficient. You're not locking up huge pools of idle capital sitting there waiting to, maybe trade against. You're matching orders directly, instantly, efficiently, and in a much more neater fashion. All right. So enough theory. Let's try and understand how you can actually trade on Injective's central limit order book. So when you open the whole trading thing, you will see that you will see a few order types. Like you get to choose from a few different order types. Now there are the regular ones like the buy and sell, which are pretty straightforward. You can either buy at the current market price or set your own limit price if you want to wait for a better deal. Easy. Now there are also this cool options called a post only order, which is labeled as buy underscore PO, which stands for post only, or sell underscore PO, right? These are special because your orders will only be added to the order book. It won't be instantly, it won't instantly match with someone else's, right? That means you're acting as what they call a market maker. I mean, not just jumping in to take someone else's trade. So the upside to such, post only orders is that you get lower fees because you are helping keep the market liquid, and exchanges love liquidity, so they reward it. That's also where the maker and the taker fees comes in. Makers add orders to the book and gets charged less. Takers remove orders right away and pay a bit more. It's a simple system that keep things fair and balanced. Now let's make it real. I mean, to understand this whole thing, let's try and actually do actual numbers example, right? Imagine Bitcoin sitting at like 42K, right? 42K dollars. You think it would dip at a bit before heading up again. So instead of buying right away, you place a limit order to buy one Bitcoin at, I don't know, 41.5K, right? That order now sits quietly in Injective's central limit order book, waiting for the price to reach it. Somewhere else, another trader thinks Bitcoin's about to drop and decides to sell one Bitcoin at 41.5K. When the next batch auction happens, and these like these run like every 6.5 sorry, 0.65 seconds, right? Injective matches your order at a fair price, and boom, you both get what you want. No bot snipping your order, no slippage, no front running, just a clean and fair trade. And that's the kind of magic here. It's not flashy or dramatic, it just works. You want to buy, someone else wants to sell, and it happens at a fair price. Now, that's how trading should actually feel like, right? Now, if you want to step things up a bit, Injective shine really starts to shine there. Like, I mean, for example, let's say you want to buy more Bitcoin, but at a different price as it drops. You can set a few limit orders, maybe one at 41.5K, one at 41K, one at 40.5K, and just let them sit there. As the market moves, those orders will automatically fill. No constant refreshing, no stress, and that's how professionals trade. They set their plan and let the market come to them. So you can also use those post only orders to always be a maker, which means you actually earn from fees instead of paying them, right? And if the market suddenly changes direction or something feels off, you can cancel your orders before the next batch auction. You're never locked in. The thing is, with these kind of stuff around, you got full control, or you are always in control. I mean, the order book itself gives you a ton of insights too. You can literally see the market's mood. Big buy walls around 40K, that's a strong support zone. Heavy sell walls around 45K, that's a resistance. Even the ratio of buyers to sellers tells you if the market's leaning bullish or bearish. And because injectives, batch auctions remove front running and MEVs, you can actually try trading strategies that usually get wrecked on other dexes, like things like arbitrage or market making or mean, reversions. They all become possible because everyone gets a fair shot. And at the end of the day, Injective basically took the best part of the traditional trading system, fixed work, didn't work on blockchain, and made it fully decentralized so that it feels professional, fast, and most importantly, fair. No gimmicks, just proper trading done right. Right. So I guess that's about it for the theory part. Now, I guess we can just go ahead and see how all this works on code. So yeah, let's jump right into the coding part. Let's go. All right, I guess we have covered a lot of theory in our previous video. Like we talked about a lot of stuff like the history of DeFi, AMMs, how order books came in, how it went away and then came back with Injective's help. So all those kind of things like we talked about in depth. Now I guess it's time we, get started with the coding and see how everything works in code, right? So yeah, so that's what we're going to do today. So I'll just give you a brief idea of what it is that we're trying to do. So let me just create a walkthrough.md. I mean, it's just, you don't have to create it. I'm just so that, explaining, I can explain things better. So okay, so what we're going to do is we are going to create an automated trading bot. Okay, so that's the agenda. So in order to help you understand all these things, what we're going to do is we are going to build an automated trading bot on the Injective protocol. Now, what's really cool about this is that it's going to be a smart contract that can actually place orders on the Injective's decentralized exchange completely autonomously. Right now, when I say automated trading bot, I wanted to understand that. I mean, I really mean it in the context of blockchains and smart contract. Like we are not talking about a Python script running on your laptop and which connects to your API, right? We are talking about a smart contract, right, that lives on the Injective chain. Okay, we're not talking about creating another script, right? And this code, which is all the properties of a smart contract, right? It's immutable, anybody can come in and verify. And the cool part is the code or the contract can actually execute trade without any centralized servers or infrastructure, right? So this is actually a fundamentally different paradigm from traditional trading bots. And when you think about it, it actually opens up a lot of possibilities. Like you have smart contracts doing trades for you, right? So now, and one of the major parts of the puzzle, like when you are building this whole thing, one of the biggest parts of the puzzle is something called as pre-compiles. Now, if you have been following along with our previous video, you already know about Injective's pre-compile because we already discussed about it in our last video, which was released on day 9th of like 30 days of solidity challenge. So you can just check in October 9th. Like you can go to the Web3Compass YouTube and check out the video on October 9th. It's about Injective, pre-compiles. Like there is a whole video on it. And in that video, we actually use something called as the bank pre-compile, right? So yeah, so pre-compiles are basically like the secret sauce that makes everything work. So so the thing is, for those who might be jumping in fresh or need a quick refresher, like let me give you a context of what makes this whole thing possible and why is this actually kind of a big deal, right? So the thing is, from our like since we are building a trading bot, the ability to build a trading bot as a smart contract isn't something that you can do on most blockchain, right? Even on Ethereum, which has like a massive ecosystem, like DeFi ecosystem, you typically can't have a smart contract directly interact with the core, exchange functionalities of a DEX in the same way that we do here or that we are going to do here, right? I mean, like with your typical smart contracts in Ethereum, you are usually limited to calling other smart contracts that implement token swaps or liquidity pools. But Injective, via these precompiles, it gives you something that's much more powerful, right? And that's what we are going to leverage today. So in our last video, we had a long discussion about precompiles, and so I mean, for those who are new, let me break this down because it's a really important concept. That actually is kind of a USP of Injective as compared to other blockchains, right? So like traditionally, when you're working with Ethereum or other EVM chains, your contracts are pretty limited in what they can do. Now, by that I mean not on the coding side, but the amount of complexity that you can do with the code, right? The amount of functionality that you can incorporate with the code. I mean, they can of course transfer tokens, they can call other contracts, they can store data, but I mean, let's say we want something deeper. Like even in Ethereum, they use precompile. Okay, like for example, like if you want to interact with deeper protocol level features of the blockchain itself, maybe some cryptography, maybe you have to do some core cryptography or verification or something like that, right? So if you want to do something that involves such core complex functionalities, you're out of luck because your smart contract lives in this sandbox environment where it can only do what the EVM allows it to do, right? So that's generally how it works. So Injective, what it did is it actually introduced these precompiles. Again, it's not something Injective started. Like precompiles are there in a lot of blockchains, even Ethereum. You can check out the previous. Again, I keep shilling the previous video, but we actually talked about this, and I think we actually showed a couple of precompiles that are there in Ethereum. Okay, so what are precompiled? So the thing is, like, based on the name itself, you get a general idea, right? They are precompiled contracts. Okay, they are also contracts, but the thing is, it is not one of those contracts where you deploy every time you want to use it. They are precompiled, and these are special contracts that already live at a special address or a fixed address on the blockchain. Okay, like you can just go to the documentation. Oh, wait, sorry. There is the yeah, yeah, okay. So yeah, you can just go to this Injective doc which talks about it. It's like highly optimized smart contracts embedded directly into the EVM. Now you know that Injective is EVM compatible, that's why you are able to run Solidity, right? So these are like special smart contracts that are directly uh, you know embedded into the core blockchain. Okay, so these things, like, they have a fixed address, right? Like our next standard Solidity smart contracts that are deployed by users, precompiles are part of the chain's core logic itself. So it's not something that you deploy every now and then. Okay, it's already embedded into your chain or the core logic of the chain, right? And they sort of act as these bridges between your smart contract code and the chain's native module, like in our case, Injective's native module. So you can think of them as like these official APIs that are built directly into the blockchain itself, right? The ones we are going to work with today, it's called the exchange precompile. Okay, we already did a video on the bank precompile, and today we are going to talk about something called the exchange precompile. Okay, so which so the exchange precompile, it sits at the address OX65. Now this is the address, and this address is fixed. I mean, if you access this address, you are basically accessing the exchange precompile. Okay, now this address never changes, and it is basically same across all the Injective networks. Okay, so today, like, let me just write it down. So in this video, we are going to, these are like special contracts that are embedded directly into the core chain logic, right? And today we are going to use something called as the exchange precompile. So this is a special contract, and it basically, you know in Injective, both in testnet and in the mainnet, it lives in this particular address. Okay, so this exchange precompile essentially exposes all of the Injective's powerful exchange functionalities, directly into our smart contract. So we don't have to write anything in order for us to trade a token or whatever, do any kind of exchange functionality. We just have to talk to this precompile. Okay, and I mean, like you can do a lot of stuff, like place limit orders, market orders, cancel orders, manage something called sub accounts, which we will talk about, query market data. So all of this stuff that you would normally have to go through a separate interface or API or some SDK, you can do it directly from your Solidity code. Okay, so that's what's really powerful about it, right? It's not some kind of wrapper around an external service. I mean, this is direct access to the same exchange engine that powers all of Injective's trading, right? So when your smart contract places an order through the precompile, that order goes into the exact same order book that all the other professional traders in the Injective network is using, right? So it's basically you are tapping into a production level code or a production level engine that powers the entire trading infrastructure of Injective, right? So that's what make I mean you know since you have all these features already pre-compiled into a contract, I think that's what makes building a trading bot as a smart contract pretty straightforward when you think about it. I mean, you're not trying to hack together some workaround or build a complex system of off-chain components. You're just writing Solidity code and you just call a couple of functions on the pre-compile, right? And those functions do exactly what you expect them to do. Okay, so it's really simple in a way, right? Like since you already have all these codes set up in the precompile, it's pretty simple. So I mean, let's just go ahead and talk about the approach that we're going to use. Like what are we actually trying to build and stuff. So let me just do approach. Okay, so today, I mean, we're talking about the kind of thing that we are going to do, and the thing is, we are deliberately taking a very simple and beginner-friendly path here. Okay, and that's actually a very conscious choice because, like, let's say, like, okay, we'll be building. Okay, so yeah, just give me a second. Okay, so we will be building a simple trading bot contract. Okay, so that's what we are going to build today. A very simple trading bot contract, and like, and I mean it. Like, it's going to be super simple. Like, we want this thing to be something that someone who is relatively new to this whole smart contract development can understand and deploy, right? Actually, without using any or getting overwhelmed by any complexity or stuff. I mean, there are ways we could make this sophisticated. Like, it's a trading bot, right? So you can always add more features, get it more, make it more optimized. You can do all those kind of stuff. But that's not the goal here, right? The goal is to create a solid foundation. So it's pretty straightforward what we are going to do. So you are the user, right? You will deploy our contract, and you will fund that contract with some Injective tokens. Fund with Injective, right? So, and then the contract can place and manage orders on the Injective spot market on your behalf. Okay, the contract is actually owner control, meaning you control it. I mean, the person who deploys the contract can control it. You can tell it what to do. Nobody else can come along and use your contract to place orders or withdraw your funds. But once it's set up and funded, it can execute trade automatically based on your commands that you give it. Okay, you call a function, pass in some parameters, like which market you want to trade on, what prices, what quantity, and the contract handles all the details of actually placing the order on the exchange. Okay, now for doing all that, we are also using something called as sub accounts. Okay, now sub accounts. Okay, so yeah, I mean, this is also a really elegant way of managing trading balances, and you can. I mean, this is pretty cool stuff because once you understand it, you can understand how the whole system works. So the thing is, like when you look at how everything works, like typically, like when you do trading, you have a main wallet account. right? Like where you have all the coins and tokens and whatever, right? So the thing is here on Injective, like trading doesn't happen directly from your wallet address. Okay, instead you have these things called sub account. Okay, a sub account is basically like an offshoot account, or is it like it is like a trading account that's associated with your main address but separate from your main wallet balance. Okay, so you can have multiple sub accounts, each with their own balances, and you can move funds between them. I mean, this might sound complicated, but the beautiful part is every contract automatically gets a default account ID. I mean, sub account ID, right? So you have like when you look at it, suppose you have a contract address, so this automatically gets a sub account. Since we are trading using the contract, this our contract will automatically have a sub account. Okay. Now, and it gets a sub account ID, and the thing is, this whole sub account ID or the identification for this sub account is actually derived from the address itself, like the contract address itself. Okay, and the thing is, it is deterministic, meaning for every contract address, there is a very deterministic way to actually find out the sub account IDs. Meaning, it is calculated using a formula based on the contract's address. So you can always figure out what it is. So, and the thing is, any fund you send to the contract address are automatically available in the sub account for trading. Right? You don't have to manually deposit or withdraw between accounts. You don't have to call any special function to move your money around. It just works. Send some injective to the contract, and the contract can immediately use it to place the orders. Right? So, and the contract itself, like our contract itself, will also expose a lot of cool functions, like place spot limit orders. There can be functions for canceling orders, maybe ways to check the balance and get information about the contract status. And we will also build in some emergency features like pausing the contract in case the board goes crazy. So all those things will be embedded directly into the contract, right? So this is the general thing that we're going to build today. And yeah, so for doing this, what we are going to do is we are going to use something called as hard hat. Okay, so hard hat is also a solidity development framework. And yeah, let's just before we start building, let me just talk about it a bit, so that you're like, in case you guys are new to it, let me just give you a quick introduction of what hard hat is.